So just recap. Oh, sorry, I haven't shared my screen. Okay, so recap what is the form of momentum equation. So the one that you see, the third equation on the screen here, is the momentum equation. And every time we talk about momentum equation, we consider two dimensions. One is on the control volume, one is on the control surface. And how, by looking at the structure of the equation, how do we know that this is a momentum equation? So just recap, what is the definition of momentum? So definition of momentum equal mass times the velocity, all right? And when we develop the equation, we use second Newton law, F equal to ma. This is a second Newton law, F equal to ma. And we can extend the acceleration in the equation over here, which is v divided by t. So when we make the products between mass and velocity here, we get momentum. So we get momentum divided by time. So if we take momentum divided by time, we get force. So that's why we can use this equation. So momentum divided by time equal to force. And since we are looking at two dimensions, one is control volume, one is control surface. So the products of this one, the V times rho, when you take the density times the volume, we get mass. Mass times velocity, we get momentum. And momentum divided by time, we get force. All right. And for surface here, we take the density times velocity times A, and then times the velocity again, we will get mass flow rate also, mv divided by t, which is give us a force also. Force at the control surface. This one, force that pass through the control volume. Okay, so these are fundamental equation that we will use. And in your coming assignment, you need to use this equation to solve. Yeah. All right. So we looked at tutorial question today. All right. Now this question is available in your handout for chapter 3. It will be under question 19. Yeah. So we're having a scenario over here. So what we have here, we have a weight or scale over here, and then we have a water tank above this weight machine. So we have a water tank that have one inlet, the arrow is showing in one inlet, and then two outlet at the bottom here. And then this tank is filled with water, and then you're trying to measure the weight of the water at any time when you have a steady flow of the water. Okay. Now we are given the dimension of the scenario here. We have a 0.61 height of the container, and then we have a cross section 0.09 meter cross section. So by taking the height and cross section, we can calculate the volume. And the metal container, when it's empty, is 22.2 Newton. So without water, is 22.2 Newton. And the container is placed on a scale, which is under there. Water flow through the two openings, 2 and 3. The opening is the same in this statement here. So under steady flow condition, the height of the water tank is 0.58. So when the flow is steady at all the opening here, the water inside the tank is 0.58. The area is given, the cross-section area is given 1, 2, and 3. The velocity is given, so the velocity is -3 meter per second. in V1. So the water is pumped into the water tank here with a speed of 3 kilometers per second. And to help you to further understand, we put in the vector unit behind the magnitude. So if you see the J hat, it means the water going along the y-axis. And then you see the negative sign, it means it go down. In all cases, if you have a positive value with the unit vector, it means you're pointing out. In this case, the water is going down from inlet number 1. All right, now this is a scenario that sometimes will happen after you go to work in the industry. So today your scenario is that your boss saying that you can just read the reading from the scale using simple static problems. Simple static problem meaning that you assume that this one doesn't moving, and then you just take the water mass, means you calculate the mass inside this mass of the water times the mg, mg mass of the water times the gravity plus the weight of the empty tank. Then you can know the weight of the water at any time. So your boss saying that you can just measure using simple static problems. However, we do not agree with the statement. We claim that we need to use flow analysis in this case, where we consider the flow coming in from 1 and going out in 2 and 3. So we will do an analysis to prove that we cannot use a simple static analysis in this case when you have a dynamic or you have a flow going in and out in our scenario. So we need to prove to our boss that we need to use a flow analysis to get a proper weight of the scale over here. Okay. Right. Now how do we start? The first we need to choose for control volume. All right. So when it comes to your test 1 or final exam, when you look at the question, it asks you to use by using momentum equation or by using continuity equation to solve certain parameter in the question. First steps, you copy the diagram into your answer sheet. Then you draw the control volume in your answer, right? So this diagram with the control volume, at least you will score 1 to 2 marks just drawing the dash line for the control volume. Okay. Then after that, you draw the free body diagram. I mean, you consider a free body diagram with the control volume. After you copy the diagram inside there, in your answer sheet, you draw the control volume, you score 1 mark for the control volume. Next, you will see the question asks you to draft a free body diagram for the question or for your solution. So what mean by free body diagram? Meaning you put inside all the forces that you can see or you can predict inside the control volume. So you will have the water of the tank, the weight of the tank, and the weight of the water. And then you have a velocity going in and out with the reaction force on the scale here. So you have vertical, 3 vertical force here. One is the weight of the tank, one is the weight of the water, and one is the outright the reaction force that measure or that counter the 2 vertical force over here. Okay. All right. Next, we will go through the governing equation. So as long as you come to chapter 3 dynamic fluid dynamic question, these are the 2 favorite governing equation. On the top, this one, if you look at the structure again, it is momentum equation, where you take the mass times the velocity, you divide by the time you get forces, right? F equal to ma again. So recall back the Newton law, second Newton law. You get the momentum equation. Second one is the continuity equation, which is we consider the conservation of mass, where there's no changes of mass inside the system, where how many you put in will equal to how many you are going out. All right, so the mass inside the system are always constant. All right, so how do you know that this is a mass? You look at the question itself. You take rho times the volume, you get mass. Mass divided by T, you get mass flow rate. So the mass flow rate is constant all the time. If you take the continuity equation equal to 0, you will get the scenario that you see in this case. Yeah. So we have the standard assumption. We have a steady flow, you have an incompressible flow, and you're having a uniform flow in each section. When it comes to exam, all these statements will be stated clearly in the question. Yeah. So in this tutorial question, some of it doesn't state clearly, but in this case, when we solve the problem, we have to come up with the assumption. So when you see the word steady flow, you can cancel something in both equation above. So if you see a steady flow, again in exam, you write these two equations out to show that you understand what is momentum equation, what is continuity equation. By these two equations, you score 2 marks, 1 mark for each, and then you draw an arrow for cancelling the steady flow. So you cancel 1 for continuity equation, you get 1 mark. You cancel 1 for momentum equation, you get 1 mark. So on the screen right now, you already score 4 marks before you substituting any number inside there. Okay, so it's very easy to score for this module. All right, so far there's nothing complex. It just tests you whether you understand what is momentum equation, what is continuity equation, and then when you apply the assumption, what can you take out? Yeah. So by saying that, you already can score at least 4 marks in this question. Then we summarize the equation so far. So the momentum equation, we only have what happened in the control surface. And then the continuity equation also, we only need to consider on the control surface dimension. All right. So let's only consider y direction. Let's only consider y direction. Now, the force component, when you talk about momentum equation, we have 2 components for the force. The total force inside our control volume consists of 2 types of forces. One is FB. FB stands for body force. FS stands for surface force. Again, body force will always link to gravitational force. Gravitational force always like to grab mass in the medium or inside the object. So body force is always equal to mg, mass times gravity. Surface force you need to calculate from the free body diagram. All right, now let's continue with the calculation. So again, we are only interested in y component only in this case. So in this case, we will only have, we will take your surface force equal to Ry. Yeah, your surface force will equal to Ry. Your body force will be called, body force will always link to gravitational force. So body gravitational force always interested in the mass. So there are only 2 things that have mass in the system here. One is your tank, one is your water. So by this information, you will have your body force equal to the weight of the tank and the weight of the water here. And the sign here is negative, negative. It is because the weight is pointing down. The weight is pointing down. It's opposite direction of the y-axis over here. Then after that, you will compose everything inside the momentum equation over here. Now for convenient, just a recall of the equation for how you find the weight of the water. You use mg, and how you calculate the mass for the water, you take rho times the volume, then you times g, you will get the mass of the water times the gravitational force, you get weight of the water. And just to recap, there's another definition. If you take the rho times g, you will get the specific weight of the water. And this one you can get from the appendix A again, the property of the water. At specific temperature, you will get the rho of the water, and also there's a specific weight in the diagram. So sometimes the question will give you a specific weight to help you to solve the question. So you need to know the relationship between rho g and gamma here. All right. So you have to know the specific weight equal to rho g. And in this case, because we are given the height of the water and also the diameter of the tank, so we can convert the volume, this volume, into area times the h. Area times the h, we get the volume. All right. So again, you need to be careful when it comes to exam. Area here, you need to look at whether the tank is cylindrical or is a rectangular tank. All right. So if it's cylindrical, then you use pi r square for the area. If it's rectangular, then you times both sides of the tank. Okay. Yeah. So in this question, let's look at whether it's cylindrical or not. Yeah, the cross-section area straight away give you already, so you can use the area in the question. So again, when it comes to test or final exam, be careful to look for the hints of the shape of the container, right? Okay. Then you combine all the force together. Yeah, combine all the force together. The next analysis we have done for the force component on the left here. Next one, we go and analyze what is the integration of your momentum in the cross section, this term. All right. So we are looking at section 1 here. Yeah, section 1 here. So at this stage, I think you should already know why we have a positive sign after we convert the products of your velocity and let me change the color first. The velocity and the products of your V dot A, you should already know how to approach this one. Again, just a recap, you always have an opening and area always pointing out of the opening of your cross section of your control volume, your opening always pointing out, and then you depends on the volume direction. So if you look at point A, the velocity is going in. Sorry, velocity is going in. You should get a negative sign. All right. Yep. So this is a velocity. So the products of your V1 and A1, if you dot products, you will get a negative sign inside the question. So in this case, you convert the outside term of V vector here into V because it's in the Y direction. Yeah, Y direction. If in X, then you use U lah. If in Y direction, you use V. And then you're still looking at the dot product here. So dot product here, you look at the diagram that you can draw at the side of your answer. Then you convert into positive or negative. So we get negative sign because of the direction of the vector. And then you substitute all the value here. So there you see V1 and dA. All right. Then the rest you just calculate from there. All right. So this is just a side note saying that you get a negative sign at section 1 there. Okay. Then number 2. is that if you look at section 2 and 3, there is no y direction of forces. We are now looking at y direction only. Yeah, so that's why we don't have velocity in y direction. In section 2 and 3, we only have horizontal. So in this case, your v for v component or y component of your speed is 0 for 2 and 3. So you don't need to go through this. A complete one you should write now. You should write A2 V rho V dot dA plus integrate of A3 same lah, V rho V dot dA. Okay, a complete equation of this total integration, it should consist of all the opening. But in this case, we know that by looking at the free body diagram, you know that we only consider y direction. So the V here we don't have. We don't have V direction. Same with the area 3, we don't have. Okay, so we can straight away calculate the answer over here. So if you integrate your A1, you'll get A1, dA1, you get A1. So from here, you get all the equation for the momentum equation, which is on the side here. You substitute all these three equation into here, and then you substitute this equation here. So that's why you arrive at the last equation that you see on the screen here. You have Ry minus W tank minus the W water, or specific weight of the water times the area of the tank times the height of the water. Okay, so you have the equation over here. All right, stop me if you're not able to understand the equation, yeah, or any positive sign or negative sign that you are confused. Just stop me and then ask me question to, maybe I can explain it one more time, yeah. Okay. Clear. Okay, we get the first equation already over here. Okay, then we substitute the relevant parameter there. You know that if you look at the velocity at y component is equal to negative v1. This is the area where students make mistakes, where they forget to put in the negative there. They'll always assume all the value must be positive. No, you have to refer to what happened to the interest area of interest there. So you have to look at when you put inside the value for v1 over here, you have to look at what happened to the opening at 1, or the area that you write as number 1 there. So in this one, the velocity at v1 is equal to v1, but with a negative sign because it's going down. Okay, so by having that, you will have this equation. You have negative v1 times negative, you get a positive sign, and v1 squared a1, like that. Then you move the negative sign, this one and this one, these two terms to right hand side, you get positive value, like that. The rest is a substitution, yeah. So this is, I just show you on the screen how you do it, yeah. So in the exam, the substitution of number also counts some marks there. So sometimes in the PowerPoint slide or in the lecture slides, I won't show you this one, but in your task or final exam answer, you need to include the substitution of number, yeah, and then you calculate. So just as a reference for your revision, the answer for Ry will be around 614.8 Newton, yeah. So we get our Ry after we substitute all the value over there, yeah. Again, in this case, the question gives you convenient. where it straight away give you 22.2 Newton. So when the come to exam, it won't be that straightforward. It will give you the mass of the tank. Maybe it give you maybe give you some mass of the tank, and you need to times the gravity force to get this value. Okay, so this question it give you convenient, it just straight give you this Newton, but in test it won't be that straightforward. It will give you mass of the tank, how many kilo, right? How many kilogram? Then sometimes I give you in ton, T-O-O-N-E, ton. 1 ton equal to 1,000 kilogram. Yeah? So sometimes I give you in ton, so you need to convert into kilogram, then you times the gravity. And since you already reached year 3, so when you come to degree level, your gravity is 9.81 for G. Don't use 10. No longer use 10. All right. All right, we have clear for the first tutorial question. Let me see the time.
Sir?
Yes.
Just to be clear,
Yeah.
The area in the formula of specific and an area and height of the weight of the water.
Oh, you mean this one, is it?
Yeah,
this
yeah.
one, is it? Yeah, I think there's a typo error.
Okay.
Let me see. Let me see. Sometimes there's a typo error. When I type, I forget to put in. I think the area is 0.99, 0.009.
So I use this, yeah. I use this area for this.
Yeah, correct. Because the area of the water is the same as the water tank.
Oh yes, okay.
Yeah. Sorry, I'm drawing the wrong position there. It should be area of this one and this one. No, I don't think I write the wrong one. One is the water. Okay, you see, there are two areas there. So
yeah.
I think correct lah.
Why,
I think correct.
Yeah, that's why I think it's correct. So
yeah, so you see, one is the 0.99 is the water. This one. Yeah. This one is to calculate the water weight, the weight of the water, weight of the H2O. And then the 0.991 is more on the control surface one, and more on the control surface dimension there.
Okay.
This one, yeah. So it is correct. Yeah, it's correct. Yeah. All right. Do you think you can go for one more tutorial without break?
Yes.
Can I
Yeah,
cool?
sure,
Okay.
sure.
Yes.
All right.
Yeah,
So
sure.
we go for next tutorial question, which is in your handout, question 20. All right. Now we have a pipe here where we connect this section to one of the connector here at station 1, and the flow is flowing from the left to right, and you can see here the area is decreasing as it's reach number 2 here. The axis is given y and x here. So it gives you water flow steadily. So you look at the word steady here. It means you can cancel something in the momentum equation and also continuity equation. And is go through a 90-degree turn. At the inlet, which is here, inlet of the elbow, absolute pressure is given. The cross-section area is given. And the outlet cross-section also given. Velocity is given. Elbow discharge to atmospheric here. Yeah. Determine the force required to hold the elbow. Means we need to find the holding force at this area. Okay. So there's some force that hold this portion in place. So we need to find the force. Okay. Now in your mind, you should know the SOP, the standard operating procedure. The first step you do what, second step you do what. So if you go through the previous tutorial, we always apply the same steps. Yeah. So the first, you look at what is given. Then you copy all the parameter out. Pressure is given. Area is given. Velocity is given. So velocity, have a practice for this module. When you are given the volume, not volume, velocity, always input the vector form there so that you remind yourself that there is a direction for the velocity. So this is just to help yourself to solve the question correctly. Rather than if you do not write this vector out, you might assume that this one always going to x direction or y direction. Sometimes it's in another direction. So we have to put in the direction. So in this case, we have negative 16 j head, which is going down because of the axis y going up. Okay. Now the next one, you should already know you should draw control volume. Now, how do you draw control volume? It's always able to contain the system that you're going to analyze. So you convert the diagram above here to the one at the bottom of the screen here. So you have a square control volume where your velocity go in and velocity go up. So by this case, you already can know the vector form of this opening here. So again, when you look at number 1, section 1, you always have one opening, area always going out, velocity going in, section 1. So you know that later if you use momentum equation or continuity equation, the products of V1 times A1, maybe A1, will give you negative sign. So then you look at section 2, you draw the control volume section 2, you draw the opening. So this is 2. So opening, always the area always pointing out, area 2. However, you need to look at the velocity component based on the diagram. So the velocity going out like that. So by looking at the 2 arrow here, you know that the products of V2 times area 2 will give you positive vector products. So before you write the equation in your mind, you should always practice something like this in your answer. And if you draw this one out for information, if you draw this one out, I will give you some marks, maybe 1 mark for this diagram. So it's easy to score for this module. Always have some drawing inside the answer, then at least I can help you to give you some marks. Just in case you do not have the correct final answer. Maybe you press the wrong calculator, the button you press, you press wrongly, then you get the wrong answer, but I'll try to find marks for you in your answer. All right, so yeah. Just don't give the empty answer. Let's say if really you don't know how to answer, then have some drawing and write something on the answer sheet. Okay, now after you have the control volume diagram, you go ahead and pull out the governing equation. In this case, because we expose the control volume exposed to the atmospheric pressure, so we will consider on the gauge pressure in this case. We will use gauge pressure. So one of the hints in the question is that when the question answer, when the question mention atmospheric pressure, most of the time you can cancel it and then straight away use gauge pressure in your calculation. So the next diagram you see on the screen here is the free body diagram that help you to understand what is happening in the background. So originally, if you look at the free body diagram from the control volume here, you have pressure 1 that going into the section 1 here, plus the atmospheric pressure that acting on all the four surfaces of the control volume, plus the Rx and Ry, the reaction force in Rx, Ry and Rx. Yeah. Why is important to find the Ry and Rx? It will help you to choose in practical way. You will choose the material of the locking mechanism of the pipe. So by looking at the X component, you know that how many forces, minimum forces you need for the material over here, and what is the material you need for the material in the vertical direction. All right, and the combination of these two vectors, Rx combined with your Ry, you'll get resultant forces or R total at a certain degree. So this one, sometimes the question asks you what is the total reaction value. It will be the square root of Rx square plus square root of square of your Ry. Okay, this one you learn in your vector chapter or your trigonometry chapter to find the reaction the total for total vector if you're given two individual vector. So how you find it? So this is how you find it. You get the square of these two number. Okay, and then how you find the angle? You use the trigonometry. Tan theta equal to Ry divided by Rx. All right. So opposite divided by side, you get the angle. So then you do the inverse of the angle. You get tan inverse equal to this one. Yeah. Then you get in angle. Okay. Yeah. So this is just a side note, just in case the question asks you to find the total reaction force. This is how you find it. Yeah. Okay. Then you take out the atmospheric pressure. The final diagram that you have, you only have the pressure gauge minus you only have the pressure gauge on the left hand side. You have the Rx, Ry, and the weight of the water going down. Yeah. Now in this case, I think you do not consider the weight of the pipe here. So if the question asks you to consider the weight of the pipe, then you need to consider. In this case, by looking at the diagram here, I don't think it included the pipe weight. It only consider the weight of the water. So again, in test, read carefully the instruction. It might be in section 1, it asks you to calculate the reaction force, Rx and Ry, by only considering the weight of the water. Then when it comes to section B, it will ask you, find the reaction of Rx and Ry by considering the weight of the water and the weight of the opening, this one. So maybe the question will add in more information for you to do analysis. And then it will ask you to find the differences between case 1 and case 2. So this is how it's going to work when it comes to your final exam or your test. Okay, the next steps is just call out the two equation that we see so many times. The first one is the momentum equation. The second one is the continuity equation. Then you look, the next step is the assumption. So we have a steady flow. Go ahead and cancel the first term of the equation. So by looking at the screen, the equation on the screen here and the cancellation that you do, again, these slides or this kind of answer will give you 4 marks. Equation, 1 mark for each, and then the cancelling of, you draw arrow right steady above the arrow or below the arrow also can. It will give you 1 mark each. So you will score 4 marks by all this notation. So after that, you further simplify the equation. So your momentum equation, you only have control surface component. Your continuity equation also have control surface dimension only. Then in this case, because we are looking at reaction force at point 1, so reaction force we have x and y direction. So in this case, we consider x component. We consider x component, then we see what happens. So you write the momentum equation in x direction. So all the force in x direction, you have two component of force. One is body force, one is the surface force. So you know that body force is linked with gravity. So in this case, your gravity going down, so there is no body force in x direction. Surface force, yes, there is a surface force there. And then you convert the second term, the term on the right hand side of the equation, with the integration of the control surface here. So you convert the first term here. So your u, the capital V, this one, you convert to x direction. It becomes small u. And then after that, you substitute the products of V times A. You draw out the diagram for section A. What is the direction of area? What is the direction of velocity? V1. You get positive or negative, then you substitute inside the equation. All right. So in your answer, the next step you have for your fx here, for your fx term, you will have, if you look at the free body diagram, you have pressure and Rx. So pressure, how you convert pressure into force? You just force equal to pressure times area. Or you just recall the pressure definition, pressure equal to force divided by area. You rewrite the equation. So you take gauge pressure times area at section 1 times the Rx equal to right hand side integration component. Then the next you just do the simplification. All right, because we're interested to find Rx, you write the equation, you further simplify the integration part. I think you can understand why this one become negative when you move from this step to these steps. Yeah. Then you have the final equation, like what you see on the screen here. Rx will equal to negative P gauge times the area at section 1 equal to negative rho V square A1, because you know that your U1 equal to V1 component here. So you have rho V1 square A1. Okay. Next, because in this direction, in this equation, we do not know the magnitude of V1. The V1 do not given in the question. So you need to use the second equation, which is the moment, the mass continuity or mass or continuity equation, to a conservation of mass equation to solve for the V1. So how do we solve for V1? You copy the continuity equation, integration of rho V dot dA. And continuity equation, look at the whole system. Continuity equation, look at the whole system. Whole system, you have point 1 and point 2. So you have integration of point 1, section 1, and integration of section 2 equal to 0. So you can convert the products of V dot A into this form. So you should know why this one negative. Why V2, there's a negative there. V2. Let me see. V2 should have positive. Because if you draw opening of A1, A2, and V2, the product should be positive. So there is no negative here, yeah? that typo error over here. So there's no negative. All right, so after that, you rearrange the equation. You will get V1 equal to V2 A2 divided by A1. You move the negative to one side, then you balance the equation. You want to find what is V1. V1 equal to V2 A2 divided by A1. Then after that, you take this V1, substitute back to the previous equation. Right? Oh, V1, you have all the parameter, V2, because in this case, V2 is given. So you can calculate V2 times the ratio of the two area there. Yeah, you get 4. Okay, so if you look at the question, let's see what we have. Okay, question. Yes, we have the velocity at section 2, which is 16. So when we substitute, we get the velocity, the magnitude of the velocity is 4, 4 meter per second. Then after that, you substitute inside this equation, right? You do all the calculation. You get Rx equal to negative 1.35 kilonewton. So in this case, you should know that when you get a negative in your analysis, it means that what you assume in the free body diagram is wrong. So if you draw the free body diagram, right, the Rx you put in this way, Rx equal to negative 1.35 kilonewton. If you write like that, is correct. The real scenario, the Rx will be going this way. If you draw going to the left, it will be positive value. Yeah? It depends on the arrow that you draw. Both diagram have the same meaning. Have the same meaning. So on the right will be same as on the left diagram here. It's only you need to understand what is the meaning of negative in your answer. Negative means what you assume earlier is the direction is wrong. But if you draw back the free body diagram with the arrow of the original diagram, you must use back the negative in answer. However, if you flip the diagram already, or you already flip the direction, remember to take out the negative sign in front. Yeah? Okay, then the next one, we consider y direction. We do it one more time. So you repeat the same for y direction. You'll get by plus bs, and then you change the v, the capital V into v, and then you look at py. So in this case, we ignore the by. Yeah, ignore the by. And we only consider what happened to the Rx over here. Yeah. So Ry equal to integration of V rho V dot dA. And you should know why if you consider section 2, if you look at section 2, you only have the positive sign. And then when you substitute your V2 here, be careful. So your V2 is your V2 is negative V2 sign. Yeah? Because this one, the velocity is going down. Your y is positive going up. Your y is positive going up. So when you convert the velocity into a magnitude, remember to know the direction. Yeah, because the products of this side will give you the force. The force have direction. Force have direction. So be careful on the positive and negative sign. Yeah. So this is the area where students will make mistakes, where they forget that V2 is negative sign in the J direction, J hat unit vector. So be careful in the exam. Yeah. The next is just substitution of all the parameter. Then you get Ry equal to negative 639 Newton. So with this, you have your Ry and Rx already. So you can find the total reaction force if the question asks you, right? You can find the reaction angle also if you want, yeah, if the question asks you also, yeah. So with this, we finish the 2 tutorial discussion. Let me stop the recording.